Welcome to Daily Curiosity.
The program where we discuss an interesting topic and teach some useful English along the way.
Daily Curiosity.
For curious people.
Hello and welcome back to Daily Curiosity. I'm Carl.
And I'm Jane. Today we're looking back 40,000 years to solve a cold case murder. Carl, how do you think the Neanderthals went extinct? Was it climate change, starvation, or was it a massive war with modern humans?
That's the classic story, isn't it? Homo sapiens arriving with better spears and just taking over. It sounds like a prehistoric battle movie.
That's what many used to think, but a new study suggests a much quieter, more mysterious cause. It wasn't about who was better at fighting, it was about who was better at reproducing.
So it wasn't a war, but a genetic mismatch?
Exactly. We know that humans and Neanderthals interbred. In fact, most people today have about 2% Neanderthal DNA. But researchers at the University of Zurich found a strange incompatibility in a gene called PIEZ1, which is responsible for carrying oxygen in our blood.
Oxygen? How does that lead to extinction?
Well, it all comes down to how we breathe. It turns out that Neanderthals had a specific variant of this gene that made their red blood cells grab onto oxygen like a magnet. Such trait was very predominant among Neanderthals. So if a human and a Neanderthal fell in love with each other and later had a baby, that baby, a hybrid, would have blood that held onto oxygen very, very tightly.
Okay, but I can't understand one thing. If they have high oxygen blood, doesn't it sound like a superpower rather than a death sentence?
It's fine for the baby, but the nightmare starts in the next generation. Imagine that hybrid baby grows up to be a mother. When she gets pregnant, her blood is stingy. It holds onto the oxygen so strongly that it won't let enough of it pass through the placenta to her own fetus.
Wait, let me see if I've got this right. Neanderthal blood was very good at holding oxygen, so if a mixed heritage mother carried a baby, her blood would keep the oxygen instead of passing it on. This meant the baby didn't get enough oxygen, right?
Yes, exactly.
Wow, I see. So the mother's biology is accidentally starving her own child of oxygen before it's even born?
You got it. And while this might only happen in a small percentage of cases, it created what scientists call an extinction spiral. Because the Neanderthal population was already quite small, even a minor 1 to 2% hits to their birth rates meant they couldn't replace their numbers fast enough.
That was a slow, tragic ending. It explains why we have Neanderthal DNA from fathers in our history, but no mitochondrial DNA, which only comes from mothers. The hybrid mothers were the ones struggling to carry babies to term, resulting in massive miscarriages.
It's a huge breakthrough in understanding our history. It shows that extinction doesn't always happen suddenly. Sometimes it fades away quietly over thousands of years.
It's also a reminder of how fragile a species can be when its environment or its genetics change just a little bit. Seeing a whole species disappearing just because of a mismatch in their blood is truly disturbing. But Jane, does this study have any impact on us today?
Actually, yes. The researchers found that some modern, unexplained pregnancy losses in humans today might be caused by similar mutations in that same PIEZ1 gene. It's a 50,000-year-old mystery that is helping doctors understand medicine today.
Science truly is the ultimate time machine. Now, before we go, let's break down the prehistoric vocabulary from today's episode.
First, we have Homo sapiens. That's the scientific name given to modern humans, our own species.
Next is the verb interbreed. It means when two different species or groups mate and produce offspring. For example, humans and Neanderthals could interbreed, which is how some of their genes ended up in us.
Then we have the collocation go extinct. It is used to describe a situation when a certain species completely disappears and no members of it are left on Earth. Like the Neanderthals, they went extinct around 40,000 years ago.
We also use the word fetus. This refers to a developing baby inside the mother before it's born.
And if a fetus doesn't develop properly or the pregnancy can't continue any longer, the result is usually a miscarriage.
And finally, the word mismatch. It means when two things don't fit or match properly. For example, in today's episode, a mismatch between the mother's blood and the fetus's genetics could prevent enough oxygen from reaching the baby.
It's amazing how much our DNA can tell us about people who lived 50,000 years ago. Thanks for joining us on Daily Curiosity.
Stay curious and remember, your DNA is the greatest history book ever written. Bye for now.
Goodbye.
Welcome to Daily Curiosity.
The program where we discuss an interesting topic and teach some useful English along the way.
Daily Curiosity.
For curious people.